7.3 part 2. You guys watched the video. We're going to talk about partial fraction decomposition. So we're going to do the first couple examples again just to practice. On this page, it explains the steps that we're doing in words. So with these types of questions, it's really the same steps every time, same pattern that we're doing. So once you get the hang of it, it shouldn't be too challenging because it's the same steps. So if you ever get lost and you're like, oh, what do I do next? Come back and check out this page and see if you can match up what step you've already done with what's coming next. So the first step is always factor the denominator. Some of the questions in the notes, and I think some on the web assigned, were already factored for us. So then it already does the first step. So you don't have to worry about that. But you always want to factor the denominator. Then you want to split the fractions for each term in the denominator. Give the numerator A, B, C, and so on, depending on how many fractions you have for each fraction. Then you want to set the initial expression equal to A times the missing term. So we want to multiply by the missing term. So we set the initial expression equal to A times the missing term, plus B times the missing term, plus C times the missing term, and so on. It's not just the initial expression, but the initial numerator. Then you want to find the values of x that would make each term cancel one at a time, and then plug that value for all the x's and solve for the constant, and then repeat for all constants. So let's look at example 6. The denominator is already factored for us, so it already does the first step. We're going to break that apart into different fractions. So we have a over x minus 3 plus b over x plus 5. Now when you factor, if you had to factor the denominator, it doesn't matter the order that you write your denominators in, because a will always be, like, whatever value you get, it'll end up being the same fraction. So it'll end up working out. It doesn't matter if you have a over x plus 5 and b over x minus 3. The order doesn't matter. You'll work out the numbers and it'll make sense at the end. Next step, we want to multiply it by the missing denominator. So in our first fraction, we're missing x plus 5. In the second fraction, we're missing x minus 3. Then we want to set up an equation. So we're going to set up the numerator and set that equal to a times the missing factor plus b times the missing factor. So we have 6x plus 14 is equal to a times x plus 5 plus b times x minus 3. Everybody with me so far? Next, we want to plug in values for x that are going to make a and b cancel. To do that, we want to find what makes our denominators equal 0. So we are just going to set them equal to 0 and solve. So the first one, I have x minus 3 equals 0. What does x equal?
3.
X equals 3. And then the second one, I have x plus 5 equals 0. What does x equal? Negative 5. So just solve for x. Set the denominator equal to 0 and solve for x. So I'm going to plug in 3 and negative 5. One at a time. We'll plug in 3 first. We're going to find a value. Then we'll plug in negative 5. So let's plug in 3. So we're plugging in 3 into all of our x's in this equation that we have. So we've got 6 times 3 plus 14 is equal to a times 3 plus 5 plus b times 3 minus 3. So 6 times 3 would be 18. And 18 plus 14? 32, perfect, is equal to 3 plus 5 would be 8a. What's 3 minus 3? What's 0 times b? It cancels out. So that would be 0b goes away. You're always going to get things to cancel in this step because we're going to be just finding one of our variables at a time. So here we're solving for A. We need to figure out what A is. So B cancels, it goes away. So from here, what would we do to solve for A? Divide by 8, so A equals 4. Perfect. Bless you. So we found A. We're going to do the same thing to find B. So next, what am I going to plug into X? -5. Awesome. So we're going to plug in -5 into our X because that was the second value we said that will make our denominator 0. So when we plug in -5, we have 6 times -5 plus 14 is equal to A times -5 plus 5 plus B times -5 minus 3. So 6 times -5 would be -30. What's -30 plus 14? -16. Awesome. What is -5 plus 5? 0. So the A cancels. The A goes away. So now we're just solving for B. Here we have B times -8. -5 minus 3 would be -8B. So divide both sides by -8. What does B equal? 2. Perfect. So once we found A and B, we're going to plug that into our fraction. So be careful in this step. Make sure A is plugging into A, B is getting plugged into B. Sometimes you might solve for B first, but just be careful, plug B into your B. So it matters which number is on top of the other. So here, when I plug in A, we've got 4 over X minus 3 plus 2 over X plus 5. So this is our partial fraction. This would be our final answer. On the homework, there's some questions where it says solve. This is how we would solve. Some questions say do not solve. For the questions that say don't solve, you would just leave it like this with your A and B as just A and B. So you just break it apart into the fractions. You're factoring your denominator. This would be if it says do not solve. So there are some questions on the web assigned that say do not solve. You just leave it with A and B. You don't have to find what A equals or B equals. So looking at example 8, first thing we want to do is factor our denominator. How would we factor our denominator here? Awesome. Take out an x, and we're left with x squared minus 4. So we take out the GCF. How would this factor?
X minus 2, x plus 2.
Awesome. X minus 2, x plus 2. Now we want to break it apart. So our first fraction is going to be A over X plus B over X minus 2 plus C over X plus 2. Now if you had it the other way around, if you had X plus 2 first with the B on top, that's fine. It'll all work out to be the same answer in the end. So the order does not matter. So we've got 3 pieces to our fraction here. What do we do next? Not yet. I mean, you can because we're going to have to do that. But what else could we do? How would we set up our equation? Set what equal to the numerator? We're missing one step. Do I need to multiply anything to the A, B, and C's? What do we multiply? Awesome. We multiply by what's missing. So we have A over X. We're going to multiply by the other denominator. So we're going to multiply by X minus 2 and X plus 2 to A. B is going to get multiplied by X and X plus 2. And C is going to get multiplied by X and X minus 2. So we multiply by the missing factors. Then we can set the numerators equal to each other. So we're going to set up our equation. So our equation here is long. We've got x squared plus 12x plus 12 equals a times x minus 2 times x plus 2 plus b times x plus 2 plus c times x minus 2. Now, how can we find out what we're going to plug in? Set the denominators equal to 0. So I can say x equals 0. So I'm going to plug in I'm going to plug in 0. Sorry. X minus 2 equals 0. So what does x equal? 2. And then the third one, x equals negative 2. Awesome. So we've got our 3 values that we're going to plug in here. So it's a little bit more work than the last question that we did, but it's okay. We've got A, B, and C to find now. So let's start by plugging in 0. So I have 0 squared plus 12 times 0 plus 12 equals A times 0 minus 2 times 0 plus 2 plus B times 0 times 0 plus 2 plus C times 0 times 0 minus 2. So on the left side of our equation, we're just left with 12 equals, here we have A times negative 2 times positive 2, so negative 4A. Then we have B times 0. What's B times 0? 0. So this whole thing goes away because it equals 0. What about C times 0? 0. So this whole thing goes away. So we're just solving for A from here. What would we do next to solve for A? Divide by negative 4. So what does A equal? Negative 3. So we're going to plug in negative 3 for A. That's going to be our final answer, but we still have to find B and C. So what can we do next?
Plug in 2.
We want to plug in 2. We want to move on to our next x value. So let's plug in 2. So we have x equals 2. So we're going to plug in 2 to all of our x's. So 2 squared plus 12 times 2 plus 12 equals A times 2 minus 2 times 2 plus 2 plus B times 2 plus 2 plus C times 2 minus 2. So on the left side, 2 squared would be 4 plus 24 plus 12. Then we have A. What's 2 minus 2? 0. So this cancels. For B, 2 plus 2 would be 4. And what's 4 times 2? So we've got 8B. And then for C, what's 2 minus 2? 0. This cancels also. So you can keep an eye out for the ones that cancel. You don't even need to write it down. Just save yourself the work. If you are organized with your steps and you know that you're going to only be solving for one thing in each equation, 2 of them are going to cancel. So you don't even need to write this part down. I'm writing it to show you. Look, it does cancel because it equals 0. So we have 4 plus 24 plus 12. 40 equals 8B. What would we do next? Divide by 8. So B equals 5. Perfect. We're going to plug 5 into our B, but we'll save that for the end. How would we find C? What do we do next?
Plug in negative 2.
Awesome. We still have negative 2 to plug in. So let's plug in negative 2. We're going to do the same thing. So x equals negative 2. We've got negative 2 squared plus 12 times negative 2 plus 12 is equal to A times 2, negative 2 minus 2 times negative 2 plus 2 plus B times negative 2 times negative 2 plus 2 plus C times negative 2 times negative 2 minus 2. So we're going to solve one step at a time here. Let's start with our left side. Negative 2 squared would be 4 minus 24 plus 12 equals, if you want to keep solving your left side till you get a value, you can do that. I'm going to move on to the right side for now. What is negative 2 plus 2?
0.
0. So this cancels. Here again we have negative 2 plus 2. So what happens to the b? Cancels. It goes away. b times 0 would just be 0. And then here we've got negative 4 times negative 2. What's negative 4 times negative 2? 8. So 8c. Then on our left side, we have negative 4 minus 24 would be negative 20. And negative 20 plus 12? Negative 8 is equal to 8c. What do we do next? Divide by 8. So what does c equal? Negative 1. Now let's take our three answers for A, B, and C and plug them in. Be careful that A gets plugged into A, B gets plugged into B, C gets plugged into C. So we have negative 3 over x plus 5 over x minus 2. C is negative 1, so this would be minus 1 over x plus 2. So because it's negative, it changes the sign to be a minus instead of a plus. So this would be our partial fraction. Some things that I want to note for the homework. So some of the homework questions say set up but do not solve. So it just wants the fractions. One other type of question that you'll see, let's say I had something like, we'll say 2x plus 5 over x plus 2 cubed. Now, if you have something that is squared or cubed or to the fourth power in your denominator, it's not just breaking it up into x plus 2 times x plus 2 times x plus 2 in your partial fractions. The partial fractions get a little bit different here. We want to break it up into x plus 2, but the next one's going to be x plus 2 squared. So we just increase the degree by 1 each time until we get to what our original question said. So this we would have a over x plus 2 plus b over x plus 2 squared plus c over x plus 2 cubed. The same rules apply. It doesn't have to be a binomial squared. Let's say I had 5 over x cubed. Same rules apply here. We would have a over x plus b over x squared plus c over x cubed. Or if this was x to the fourth power, let's say, then we'd have plus d over x to the fourth power. So you just keep going until you get to the degree that you have in your denominator. So there is a question like this in the homework where you have to set it up. If you have something that is squared or cubed or to the fourth power, you need the base of it and every degree leading up to it. Yes. One other thing, if we have, let's say, I'll make one up here. Let's just say we have 1 over x plus 5 times x minus 2, something like this. We've got a over x plus 5. This does not work out. I just made this up, but I want to show you b over x minus 2. And let's say we got a equals 3 over 4 and b equals negative 1 over 2. When we plug them in, we don't want a fraction in a fraction. So whatever's in your denominator is going to go in the denominator of your partial fraction. So here we would have 3 over 4 times x plus 5. And WebAssign wants you to distribute it. So you have to distribute for the homework. So this would be 3 over 4x plus 20. And then same thing with the b here. It would be minus, because it's negative, 1 over 2 times x minus 2, but you have to distribute, so it'd be 2x minus 4. So the homework is pretty particular with how it wants the answer. If you have a fraction, your numerator of the fraction is going to go in the numerator, denominator is going to go in your denominator, but you need to distribute. And make sure you pay attention to the directions on the question. If it says to solve, it wants you to find what A equals, what B equals, what C equals, just like we did in the questions from the notes. If it says set up but do not solve, you're going to leave it like this with the A, B, C. So if it says set up but do not solve, it wants it just with the A, B, and C, but it does want it as a fraction.